Well, there's always a wonderful introduction from Martin, and I literally did come more or less directly from the airport, so I'm probably several time zones away still. My mental state will catch up with my physical state sometime this afternoon, I hope. In my role as CTO of Intel, I'm responsible for leading the primary research organization of the company, which is known as Intel Labs. And we embarked on an exercise, probably half a dozen years ago now, to rethink what industrial research meant in the 21st century. And I have to give due credit to Paul Otellini, the outgoing CEO. He retired last Thursday because in one of our very first face-to-face meetings, he asked me a very simple question. He says, I don't know whether Intel Labs should be half as big or twice as big. What do you think? And I was like the questions Martin was getting a moment ago. I went, well, that's a really interesting question. Why don't you let me think about that for for a little while? And from that one question, basically began a transformation of what it meant to do research at Intel. And we think the lessons learned are broadly applicable literally around the world. And just within the last year or two, I've sort of been out on the stump, I guess the politicians say, trying to bring this message of 21st century industrial research to all the countries I visit. And I'd like to share that with you today. I guess I haven't been trained on this, but it says next. Whoops. Maybe we can, yeah, okay. So there's an extra build in there. But, there's always discussion about the difference between invention and innovation. People wrap lots of words around it, never quite sure exactly what distinguishes it. But we've spent a lot of time thinking about this because what we believe characterized 20th century industrial research was a principal focus on invention. And what we think will characterize, and has begun to characterize 21st century research is this focus on innovation, which I think is one of the reasons why we're here today, is to focus on innovation over invention. Nothing better than a really hard example. So the one that's illustrated here is the invention of the point contact transistor on the left and the planar silicon transistor on the right. If you look at the invention of the point contact transistor, which was done at Bell Labs, I think announcement was in 1947, the team of Shockley and yes, I'm going to get Bratton, and help me with the last one, Bardeen. And basically this was, announced with great fanfare. There was a Nobel Prize that followed a few years afterwards. And then Shockley left to form Shockley Semiconductor. Interestingly, among his employees were Robert Noyce and Gordon Moore. Now they joined Shockley expecting to be, part of the commercial development of the transistor. But as you can see on the left, the point contact transistor was not really a manufacturable design. And they had high hopes that at Shockley that they would figure it out. But Shockley personally preferred to be in the Bell Labs model and operated Shockley Semiconductor primarily as a Bell Labs-like research organization focused on invention. So Gordon and Bob and I can call them by the first name because I worked with them for many years, went off on their own. You may know the story of the traitorous eight that went off and formed Fairchild Semiconductor, where again they focused on innovation, which was how do we take this seminal invention of the transistor and make it commercially interesting. That hadn't happened at Bell Labs, and more than a decade had passed since the invention. And Gene Horney, who was at Fairchild, was part of that team, came up with the transistor you see on the right, which is literally the foundation for everything we know today in semiconductor electronics. In fact, there's this wonderful quote from the historian Christopher Leclerc, which says the planar transistor was the most important innovation in the history of the semiconductor industry. And I think that's more or less an inarguable statement. This is what revolutionized electronics. And the planar transistor was the inspiration that Bob Noyce needed to invent the planar integrated circuit. And as they say, the rest is history. So the conclusion, the takeaway here is that research which focuses solely on invention doesn't really produce the kinds of results that corporate boards and chief executive officers are looking for today. They want research that focuses on innovation, that provides the insight, the understanding, the breakthroughs that lead to product and services that make those businesses successful. So to just give it to you in a few words, we believe industrial research in the 21st century must target this notion of a measurable return on investment. In fact, many of the subsequent conversations that I had with Paul Otellini in the intervening years continued to come back to this question: how is the research that's underway at Intel Labs impacting the bottom line at Intel? And we spent many hours within the labs talking about this and really coming to understand what it takes to deliver that kind of innovation-focused research. So here it is in a nutshell. Just remember this one slide. Those of you who are responsible for industrial research organizations or are thinking about creating industrial research organization, it's all right here on one slide. It starts with having a vision, or in our case, since we deal with many technologies at Intel Labs, having many visions. And we employ many techniques to create those visions. One of the most popular ones is something our resident futurist, Brian David Johnson, created a few years ago, which is science fiction prototyping, which is the notion of using science fiction as a way to explore the impact of technology on society, and to use the learnings that come through the writing of stories to create a vision of the future that is one we can all find attractive. So setting a vision. Next is inventing and validating. And inventing, I think you already understand pretty well from the previous slides. Validating, I think, is something that is often overlooked, but in my experience at Intel is really a fundamental notion. Many ideas come along. Many come from the academic sector. Many, are created internally, organically. But often there's sort of a rush to get these new ideas into product, and time is not taken, or adequate time is not taken to really validate the idea. And I can tell you, we've had a few multi-billion-dollar mistakes of this sort at Intel. Privately, I'll be happy to discuss the specific products I'm talking about. But as Martin pointed out, we put $4, $5, $6 billion into this big hole in the ground, and we don't know what we're going to build with the factory that rises from that big pile of dirt. And if you guess wrong, it is an incredibly expensive mistake. I mean, that's sort of life in the semiconductor industry. And by failing to validate some of these ideas, we've let these errors go all the way to product and into production, and only then did we begin to realize that we hadn't done our homework and the product had fundamental flaws. So validating is, if you will, an equal partner to invention. It's very important to take the time to make sure you've got it right before you commit product. And finally, venturing, and this is really the newest element, but of this notion of 21st century industrial research. Many companies have venture arms. Intel's had a venture arm for many years, Intel Capital. I think it is the largest private capital entity, organization, whatever you want to call it, in the world. Has something north of 600, maybe as many as 800 companies in its portfolio. But it was sort of off by itself and primarily funding things, well, not primarily, exclusively funding things on the outside. And again, a conversation between myself and Paul Ottolini and Stacy Smith, who's the chief financial officer. We sort of hatched this notion of venturing in the labs, which is from time to time, technologies come out of our research that don't have an obvious home in one of the business units where those ideas are turned into new products. And rather than let those ideas die, why not fund them as new ventures? Now, those ventures could be completely internal, they could be completely external, they could be joint ventures, they could be licensing arrangements. Anything is possible there. But the whole idea is not to let the idea die, but to put some money into the idea and see what comes of it. We now have 3 businesses in venture that are part of the labs, and as the line goes in Jurassic Park, spared no expense. The venture portfolio in the labs is now roughly $100 million. So we're putting our money where our mouth is. But we think this is a key ingredient. It opens up an avenue for these advanced technologies that had in the past been closed to us. I also want to talk about problem that or a question I guess I'm often asked by other CTOs from industries well outside of the semiconductor or computer industry, and that is, well, how do you get those great ideas, those ideas that will lead to tremendous innovation in products and services? How do you get them out of the lab and into the products? And this was a picture we drew on a whiteboard, half a decade ago, and the observation was, well, one of the problems in moving technology across that gap was the fact that they were not in any sort of synchrony. There was no time phase relationship between what was going on in the research organization and what was going on in the product organization at Intel. And we nicknamed the hole in the middle the Valley of Death. And we actually wrote down any number of technologies that had died by failing to cross that gap. And so we thought long and hard about what it was going to take to be successful here. And this became a central focus, not just for the labs, but for all of R&D at Intel. Lots of folks spent a lot of time looking at this. And the solution, which is really been extraordinarily successful at Intel, transfer success rates exceeding 90%, was this notion of joint pathfinding. And it's a very simple idea. We actually borrowed it from our manufacturing organization. Time doesn't permit me to give you a full elucidation of that. But it simply says, take a given technology, bring the researchers and the developers together for some reasonable period of time, and that's typically a year, sometimes 2 years, sometimes longer. We've actually kept the researchers and developers together all the way to product release. But their responsibility is to move that technology across. It's a person-to-person activity. It's not a tech report or a schematic or a chip layout. It's people working together from the research side and the development side. If you've ever wondered how it is that Intel is able to advance Moore's Law on this incredibly regular cadence, I mean, more or less 2 years, tick-tock, year after year after year, it's because of this technique of joint pathfinding. The chip technologists get together with the chip researchers, and they together define what that technology is. And they work 2 technologies ahead, because once that pathfinding exercise is done, then the developers actually have to perfect the process and bring it into the factory. But this is the secret sauce at Intel. I've also spent a lot of time thinking about and talking to folks about industry university research relationship. And we've been pioneering a new model here, and the early returns are looking quite good. In the US, we call these science and technology centers. Here in Europe, we call them Intel Collaborative Research Institutes, but the model is more or less the same, and I had better animation for this one, so I chose the US version of this. But the idea is to fund university research in what we call a hub and spoke model. So we have 1, sometimes 2 universities at the hub, and the hub school is responsible for providing the overall technical leadership. And then we have some number of spoke schools where the best and the brightest at other universities come together with the researchers at the hub school. In addition to that, we place an Intel principal investigator on campus working with that research team located at the hub school and some number of additional Intel researchers. And again, it's the physical presence of those researchers at the university that takes the quality, and more than the quality, the relevance of that research and the ultimate impact of that research to the next level. Something else marvelous has really happened here. And that is that structure that I just outlined has led to the creation of entire research communities that represent the faculty, the graduate students, and the Intel researchers all working together. We have periodic retreats and workshops for each of these centers. There are 7 of them in the US and 7 of them internationally. And they're just extraordinary. The level of enthusiasm and energy and excitement, both in the faculty and the students, is just unprecedented in my experience. And the opportunity to work with industrial researchers in an academic setting is something our academic partners value to an incredible degree. The last thing I'm going to talk about, I know I'm well over time, is this notion of network R&D. This was an idea that Martin and I hatched a few years ago. We could practically recall the exact date of the meeting, but we were struggling with how to link Intel's many R&D centers across Europe and really through networking them, create a much more powerful and effective organization. And that led to this notion of Intel Labs Europe. And, I just can't say enough about how successful this has been for us. We were a very minor, and when I say minor, I mean, almost negligible participant in the framework programs and in other funded research across Europe. And today, we're a top 10 company easily, and it's due almost entirely to this notion of creating an R&D network. If you have similar organizations scattered across Europe, I can highly recommend this structure. And again, it's energized the researchers. They come together. You can see one of the gatherings here. They come together periodically, and it's really remarkable how they feed one another and how they teach one another and how they learn from one another. And just sharing best practices is one of the extraordinary things that comes from this structure. So I'll stop there. I think I've given you sort of the highlights of what I mean when I say 21st century research. And I'm beginning to see other people moving to models like this, if not identical to this, and I'm very excited about that. I think we can make industrial research the engine of innovation around the world if we just realize that the days of the Bell Labs and the Xerox Park are long past, and it's time for a new model and a new think around industrial research. Thanks very much.